Alright, hello Common Core Algebra 2. We are going to go with our next section in Chapter 3, which is all about systems of inequalities. And we're going to learn how to graph a system of inequalities to figure out their solutions. So we have graphed linear inequalities in the past, and we've graphed systems of lines in the past, and now we're going to do a system of linear inequalities. So it's really just a combination of the two, and most of it's going to seem like pretty much review. So just as a reminder, if I take my green inequality here and I graph that, remember this is slope-intercept form, so we've got our y-intercept at -2 and our slope is -1/1. If I graph that line, it would show up right here. I've got my y-intercept at -2, I went down one, right one, down, right one, and conversely I could go up one, left one. Don't forget that this is a dashed line because it is strictly greater than. If it was also strictly less than, that would give us a dashed line. It's the or equals to piece that we see in the second one that gives us our solid line. Speaking of the second one, I would put my point for my y-intercept at 6, and then my slope is 3/1. So from 6 I'd go up 3, right 1, or I could go down 3, left 1, down 3, left 1, and I keep doing that, and I get these two lines. Now, don't forget, this is not the entire solution to our inequalities. The green one here, I need to do a test point. So if I chose the test point 0, 0, I plug that in. So I'm going to have 0 is greater than a -0 minus 2. Simplifying that, I get 0 is greater than -2. That is a true statement, which means in green, everything that's on the same side as this, I'm going to shade. So I've got all this area shaded. Okay, I've got everything here in green. That is an infinite amount of points that are a solution to that inequality. I can take 0, 0 and use that as a test point for the second one as well, less than or equal to 3 times 0 plus 6. So I just plugged in my 0, 0 for x and y. I simplify that, I get 0 is less than 6, which again is a true statement. So that means everything to the right of the red line, because that's where this point 0, 0 is also a solution to that inequality. So what I did here is I did two inequalities and I just graphed them on the same grid. We have really only been doing one inequality graphing on the same grid. Now I've done two. And that's basically what a system of inequalities is. We just have two or more inequalities with the same variable. And you notice your last two had the same variables, x and y. The solution to a system of inequalities is an infinite amount of points, like we said, that is shown on a graph by shading. And to check that solution, like we did with 0, 0, we're going to take a test point and plug in values and see if the inequalities are true. So there could be 1 or 2 points that we may have to check, or 3 or 4. Really, we could have up to 4 different regions to see where is our true statement. Practicing that, you'll see I've got 2 points here. So I'm going to start by trying over here, 3, 6. I want to check this system of inequalities. I'm going to plug in x and y into both inequalities and simplify. If they're true, the point is a solution. If it's false, it is not a solution. So taking 3, 6, plugging into that first one, I have 6 for y is less than 3 for x minus 4. And if I simplify that, I get 6 is less than -1, which is not a true statement. 6 is not less than 1. So this one is not a solution. Okay, 3, 6 is not a solution. Over here, let's try 5, 0. If I plug that into the first one, I'm going to have 0 is less than 5 minus 4, and that says 0 is less than 1. So it is a solution for that first inequality. We need to make sure we check the second inequality as well. So same idea. I plug in 0 for y, greater than or equal to. Now I have a -5 for x because of that negative sign, and plus 3. And simplifying that, I get 0 is greater than or equal to -2, which again is a true statement. So that tells us that 5, 0 is a solution. Okay, where 3, 6 was not a solution. To solve a system of inequalities, so not just checking a point to see if it's a solution, to solve it, we're going to start by graphing each inequality, like we did in that first example. Some will have dashed lines, some will have solid lines. Don't forget that important piece. And then we're going to use that test point to find the solution to each inequality. And remember, this is going to be some shaded region. That's your solution. We want to see where our shaded regions overlap. and our test point is 0, 0. Usually. Sometimes we can't use 0, 0, remember, if your line goes through there. So 0, 0 is an easy one to use. Can't always use it though. And then finally, you're going to shade the intersection of the solution. So we want to find a test point that is true for both inequalities. If that happens, that's the region we want to shade. Going back to that first example we did then, remember we had a line, that dotted line going in green here, and that solid line going through 6, 3, 6. We did the test point 0, 0. That was true for both of these inequalities like we showed. And so we had this whole region shaded in green and this whole region shaded in red. The solution is where that green and that red overlapped. So if you need to go back to that first one, go ahead and take a look at that one. But remember, that was everything in this region. So it had to be bound by both lines here. To the right of the red and to the right and above the green gives us just this one. This was also true for the green, and down here was also true for the red, but since it's not true for both, we're not going to shade those regions. We only want to shade the region where our two intersections overlap. One more example to show you, since this one can be a little bit funky. Y is greater than or equal to negative x plus 2, so remember that's going to be a solid line because we have that or equals 2 piece. I put a point at 2 for my y-intercept, and my slope is negative 1 over 1, so I'm going down one, right one, down one, right one, or I could go, remember, opposite, up one, left one, up one, left one. And I get that solid line. The second equation, sometimes we have trouble with this because we don't recognize our y-intercept. Since there's no constant added, you could just think of this as a plus 0, which means we're going to go through the origin, and now we have a dashed line, same idea, going down one, right one, down one, right one. Okay, the trick here, now in our last inequality, you saw that with these two lines that we graphed, we had 1, 2, 3, 4 regions that we shaded and tested. Here, we only have 3. We've got 1 and that tiny little region between them, and then 3, the region below. We can't test 0, 0 because this line goes through 0, 0. So I'm just going to put a point in each region. It doesn't really matter what point I choose. I could say that point, which has coordinates 4, 4. I could choose this point in the middle region, which has coordinates negative 2, 3. And I could choose this point down here in our third region, which has coordinates negative 2, negative 2. And I'm going to test each one of those points to see what happens. If I plug in, it doesn't matter which one I start. Let's just start with 4, 4. 4 is greater than or equal to negative 4 plus 2, which tells us that 4 is greater than or equal to negative 2. That's a true statement. So 4, 4 works for the green. But remember, it has to work for both. So plugging in the other, I get 4 is less than negative 4 now. That is not true. So we know that this region up here doesn't work for both equations. So we can take that one off the list because we now know that that one's not going to work. Let's test this next one in the middle. I plug in 3 for y, greater than or equal to, and then remember, negative of a negative is a positive, so that is 2 plus 2, which gives us 3 is greater than or equal to 4, and that is not true. So I don't even need to test my other one because I know it's not going to work. So that region doesn't work. Last option is negative 2, negative 2. Plugging that in, I get negative 2 is greater than or equal to. Remember, that changes to a positive because a negative of a negative. And that's 4 plus 2, or I'm sorry, 2 plus 2. I'm jumping ahead of myself. So I get negative 2 is greater than or equal to 4, which again is not true. Which means this point can also not be a solution. Since there is no region where they would actually overlap, this one we say is no solution. Okay, and the reason they don't overlap is because the green would have been true for up here, and the red, had we shaded these as two individual inequalities, would have been true for down here. And you see, their two solution sets never overlap, so we get no solution for this one. Okay, which is like having no point of intersection in a system of equations. Okay, that is it for our system of inequalities. Basically, we are just graphing each linear inequality individual. Pick a test point in each one of your intersection zones. Test those points, and the one that is true for both inequalities is the region you're going to shade. All right, we'll see you next time.